Good day. Today we're going to be looking at the vertex form of quadratic equations. The vertex form is in the form y equals a times parenthesis x minus h parenthesis c squared plus k. hk is the vertex and x equals h is the axis of symmetry. Now let's give this an example or two. On number 1, what is my h value? If you said 4, it is incorrect. Notice in the equation it says x minus h. What that tells me to do is flip the sign of this number. So this is positive 4, my h is negative 4. And k is just negative 2. Axis of symmetry, x equals negative 4, vertex, negative 4, comma 2. Let's do number 3. I'm going to flip this sign for my h value. So h is equal to positive 3. Now there is no plus or minus number at the end, but that is the same thing as plus 0. So my k value is just 0. X equals 3, 3, comma 0. Now once again, like the previous lesson, you are allowed to use Desmos to get this, but honestly it is easier if you learn how to read this vertex form. I'm going to let you try number 3 by yourself at the end of the video. For now, let's do number 4. And this one, I don't have a plus minus h inside, therefore h is 0 and k is 3. X equals 0, 0, comma 3. All right, I'm going to give you an example here and let you practice the other one. And you feel free to pause the video as needed to try these, or pause at the very end and go back and try them all at once before I show you the answers. All right, graph each equation using a table of values, identify the axis symmetry, vertex, domain, and range. Real quick, domain and range. Domain of these functions will always be all real numbers. Or you can write negative infinity to positive infinity. The range will depend on my vertex and depend on the a value. I'll show you what I mean in example number 5. All right, first I'm going to identify my h and k. Flip the sign of plus 2 as negative 2. And k is 7. X equals negative 2, k equals 7. All right, the range of this function. I'm going to first show you the table, and then I'm going to show you how to write the range. It is my recommendation to start the middle of your table with your vertex, negative 2, 7. Now I'm going to fill in both sides of this table around negative 2. So numbers less than negative 2 are negative 3 and negative 4. Greater than negative 2 is negative 1, 0. The reason for this is because of the symmetry of a parabola. Because I'm going by ones, my numbers for negative 3 and negative 1 are the same, and for negative 4 and 0 will be the same. So if I plug in negative 1 to this equation, I have negative 1 plus 2, please do not write this, squared plus 7. You can use Desmos if you want to do it, but this is 1 squared, which is 1, negative on the outside, that's negative 1 plus 7, which is 6. If you plug in 0, and I'm not going to write any more out, I just want to show you how I'm doing it. I have 0 plus 2 is 2, 2 squared is 4, negative 4 plus 7 is 3. So we see from my vertex, each number is decreasing. Therefore, my range is negative infinity up to 7. You could have done that a lot easier by looking at my a value. My a value is equal to negative 1 in this problem. If A is negative, remember it's opening downward, so it's going to be, sorry, wrong bracket. It's going to be negative infinity up to my k value with a square bracket. If A is positive, my range will be square bracket k, comma, infinity. Okay? That's how you do the range for all these problems. Now I can graph this. -2, 7, -1, -6, 0, 3, and the same thing on the other side of my axis of symmetry. Here is a rough picture of my graph. You can type it in Desmos, or you can call this good enough. Try number 6. Again, I'll show you the answer at the end. Transformations of this parent function. We're going to take the parent function, which is y is equal to x squared, the most simple version, and we're going to use transformations to change the size or position of the figure. So, for example, if I have 7 is y is equal to x plus 2, well, I'm going to flip the sign for my h value, -2. There is no plus at the end or minus, so k is equal to 0. -2, 0 is my vertex. Now on the graphs, you notice there is already a picture drawn. That is your parent function, so you can see how the transformation changed it. All right, I'm going to pick -3, -4, -1, 0, 4, 1. There's my points. I'm going to say this again, but you can use Desmos and get those. Regardless, here's my graph. So how did it change from the black line to the purple? Well, I took the graph and I moved it to the left 2 units. All right, number 8. Actually, I'm going to skip down to number 9. H is -1, K is -6, all right, that's all for the y values. Plug in your numbers. This will be -5, because it's 1 minus 6. If I put in -3, it is going to be -2 squared, which is positive. 4 minus 6, -2. There's my new coordinates. So, start my vertex, -1 down 6, 0, -5, and -3, -2, 1, -2. Here is my graph. So what happened? Well, the transformation was I moved this down 6 units, and I moved this left 1 unit. Let's look at number 12, and I'm going to leave 11, 8, 10, and 11 for you to do. For number 12, my h value is 3, my k value is -2. Now I'm going to choose 4, 5, 2, 1. Now, I'm going to show you how to use Desmos easily with these problems, because this is harder to do than the other ones if you're just trying to use it mentally. So I'm going to type in -1/2, parenthesis, instead of x, I'm going to put a set of parentheses. -3, close parentheses squared, minus 2. Now I'm just going to put in my x values that I chose. So I can try 3 if I want. I know it gives me negative 2. That would be my vertex. Let's try 4. That's negative 2.5. Let's try, I'm going to write it here. Let's try 5. That's negative 4. Now if I plot these, I'm going to go negative 3, negative 2. Let me change colors real quick. Negative 3, negative 2. Negative 4, negative 2.5. Negative 2, 2.5. Oh, that's positive. I apologize. Let me just shimmy that over in a second. Well, my iPad is not getting along with me right now. It is not getting along with me at all. Let's try this one more time, shall we? There we go. Oh, heck, let me just redraw them. That's getting aggravating. So 3, negative 2, negative 2.5, and negative 4. Now, in my opinion, that does not look very, let's say, giving me a good idea of what it looks like. So I'm going to go in and type in another point. I know 5 didn't work. Let me go to 6. Well, 6 is negative 6.5. 7 is negative 10. Well, that's off my graph, so I am going to go to 6.5. 1, 2, 3, 4, 5, 6 and a half. So here's my graph. Notice this curve is not nearly as sharp as the ones before. That's because this is a vertical compression. I'm going to infinity slower than what I would be. That's what my 1/2 does out front. So I have a vertical compression. And I'm going to put COMP for compression. I have a vertical reflection, or reflection over the x-axis. I'm moving it to the right 3 units. And I'm moving it down 2. That is all the transformations on that problem. Now here's how we're going to put it all together. You can look at the graph and I can tell you what the transformations are based on how it looks. So if I'm given the vertex form, which again is this, I know that H is a horizontal shift. Look up here, whenever I had H is equal to negative 2, it shifted it left 2. Whenever I had H as negative 1, it shifted it left 1, and K shifted it down 6. K is the vertical shift. So if your H value is positive, so it's a X plus H, then that is shifting it to the left. If you have negative, it is shifting it to the right. So for example, X plus 3 is left 3, X minus 4 would be right 4. If for a K value, if you have plus, it is up, minus is down. So x squared plus 2 is up 2. X squared minus 7 is down 7. Okay, those are just examples. If your a is negative, you're reflecting across the x-axis, you're flipping it over. If a is greater than 1, it is a vertical stretch. If a is less than 1, it is a compression. Now I want to show you something. For a vertical stretch, I have noticed students sometimes don't understand what that means. They look at that and they say, well, that looks skinnier, so it's not stretching. Well, that's not what I'm asking about. That's not what I'm looking at. I want you to look at a coordinate such as x equals 1. We're not looking at how skinny it is. We're looking at how fast does it touch. Well, not touch, but how fast does it go to infinity. So at the parent function, x is equal to 1 gives me a y value of 1. If I put 10, though, this is a vertical stretch because instead of being a y value of 1, it's 10. It is going to infinity faster, so it's stretching closer to infinity. That's why it's a vertical stretch. And if it is less than 1, it is a compression. Now, here are some special equations. You need to know these. We are not really going to talk about them too much in Math 2. You will need to know them for later. You can write them down now, or you can wait till we talk about it in another class or in a later part of this unit. But really, we're just looking at vertical in Math 2. Write an equation to represent the function. Now, I'm going to skip the first couple because they're easier. I'm going to skip to some of the harder ones. For any of these problems, what you want to do is start with y equals. You need to leave a blank space, put parenthesis, leave a blank space, put a square on it, and have space on the right side. This allows me to fill in whatever it asks. So number 16, translated 7 units to the right. Well, I know that has to be minus 7 on the inside of that parenthesis. It says 4 units up plus 4 on the outside. There is no more transformations in that statement. I just need to put an x on the inside of the parentheses. I'm finished. There's the expression. Let's try number 18. Reflected over the x-axis. So I'm going to start with y equals blank, blank, squared. All right, reflected over the x-axis. I put a negative out front. Then translated 5 units to the right, minus 5 on the inside, and 2 units down, minus 2 on the outside. There's no more transformations. I'll put my x in. There's my equation. I'm going to do number 20 and let you try the rest. Number 20, vertically, y equals space, parentheses, squared. All right. Vertically stretched by a factor of 2. A vertical stretch, factor of 2. That simply means a 2 on the outside. All right, reflected over the x-axis. I need a negative on the outside. I'm translating 4 units left, plus 4 on the inside. That is all of them. I need to put in my x, and there's my equation. It is completely finished. Now go ahead and pause this video because the lesson is done. Try the problems that we skipped. Try the ones that we did not do to see if you understand it. Go ahead and pause the video, and now I'm going to show you the answers. Not that. Here we go. So you can pause it to write down the answers for whatever you didn't get. I did not do the graphs because you do have Desmos. I have written all the transformations though. All right, we are done. I hope you have a great rest of your day, and please let me know if you have questions.